Hello and welcome. We all seen these beautiful images generated by stable diffusion and similar engines, similar like DALI and so on. So, how does they work? This is a very interesting question. So, let's try to answer this question. The stable diffusion in general is a latent text to image generator or diffusion model capable of generating photorealistic images given any text input. In general, or most of people will use it or are using it in generating or transforming text to images. However, this is not only Stable Diffusion can do. It can also generate random images, and it can also generate text to images taking into consideration an input image. So you'll have an input image, you will write a prompt, and you will generate another image. You can even train Stable Diffusion on your images and it will start generating your own images. It's very interesting. To understand Stable Diffusion, we have to first understand the grandfather of generating images, which is GAN. Well, GAN is Generative Adversarial Network. GAN is a machine learning system which have two parts, a generator and a discriminator. A generator is going to generate images from a random noise. Well, it's just a seed, a random noise. And a discriminator is going to judge if this generated images is real or not real. So you have two of these networks trying to fool each other, or the generator trying to fool the discriminator, and the discriminator trying not to be fooled. They will keep competing with each other, and as the training progress, we will get a more and more realistic images. The ones that, well, the generator is going to produce at some point is going to be enough that it will start fooling the discriminator. And for us, it's going to work well because we will get an images that looks like real images. Take in mind that the generator is not going to really see an image. He's not going to see any real image. The only thing the generator will get is a noise and a number provided by the discriminator showing how likelihood this image generated by that generator is, well, real or fake. And as usual, the training process will always be directed to reduce the loss, in which will be denoted by this min-max function, in which the generator is going to try to reduce this loss and the discriminator is going to try to maximize it. This is the simple way of how we can turn a noise into a meaningful and, well, real-like image. Now, Stable Diffusion is going to rely on solving the issue or changing the noise into an image. However, unlike the GAN, which is taking a completely random noise and turn it into an image, the diffusion process or the Stable Diffusion is going to use a diffusion process in which it will start step by step removing the noise of the image. Of course, we can use a GAN network to remove that noise, well, removing that noise, or we can use one unit encoder-decoder network, which is most likely used in Stable Diffusion. So we will have an image and we're going to add noise to it, and step by step adding noise to the image until it's completely noisy. This is, well, we consider it as our training data. And the reverse diffusion is going to take that noise image and one step at a time remove that noise. This is how we, well, train the reverse diffusion model, or we apply the reverse diffusion process. So, so this is what we simply going to do in order to get these beautiful images. However, this is, as we can see, does not answer our question, which is how can we generate an image from text? We now generating image from a noise, but in a different way and by taking a step-by-step approach. So to generate an image from text, we have to do, well, the same thing, but what we will do is to inject this text. So we'll start from a noise, as we did in GAN, as we did in a diffusion process, but this time during the diffusion process, what we have to do is to inject the embedding um, text numbers. Well, they are representing numbers. We'll take these text and embedding the transformer style embedding system, and we will inject these numbers into the unit that is going to uh, denoise our images. And as the process keep on repeating, we will step by step get our images directed to the text we are trying to, well, generate, or the image that represent the text we're trying to generate. The last issue we have is how to input image and then add text prompt to that image, and at the end we will get, well, uh, another image, or generated image, new image that represent both the image and the text. To do so, well, we have to do a little bit alteration to the text to image generator. That is, first we will get an image, well, the starting image, and we will encode this image into the latent vector. And the latent vector in a simple words is the same as the unit. However, you cut it in half in order to get the only representation numbers in the middle of this unit. After that, we will do a diffusion processes. That is, we will add noise to that latent space, and followed by that, we will add our text. And of course, we're adding our text is not going to be only text. It will be an embedding style using a transformer to to put these values, to put these numbers into the denoising uh, part of the well, the network. We will start denoising this image that already have the first image, the embedding text, or as we denoise it, it will have the embedding text, and it will we keep doing this process until we get an image that we want to generate. So this is basically how it works. We add an image, uh, embedding it to a latent space, we add noise, and then we start the diffusion, the reverse diffusion process, in which we are actually adding the text in as an embedding values, and we keep doing this process until we get the generated images. And of course, maybe last step, we need to resize it and to make it, bigger, um, increase to be efficient in regarding to the computation. One thing to mention is when you're generating your own images using stable diffusion, what you are doing, for example, if you're doing with the Dream Booth, what you are really doing is you are fine-tuning the model by adding your name as a noun, or of course, as in case you want to generate your own images, you will have your own name, and you will have the images that related with your name, that is the images you are providing, and this is how the model will start generating images that has your name into it. Of course, you don't have to use it only on people. You can also, for example, generate an image for a specific car. For example, a Nissan R34 GTR car, and of course provide the name of this car, and you will start generating images that contains this car. Of course, this is how the stable diffusion works in general. However, there are some other things in it and other complexities in it. For example, the embeddings method and how to strictly direct the generation process to match what you are trying to generate. So, in general, now we understand how it works. And of course, if we want to get to know how it works more, we have to go to the documentation and install Stable Diffusion. There are many models and there are many levels of complexity of these models that we can install, and we start playing with these variables, and this is how we can get to know more of these.